Hi guys, so Module 4. The review for Module 4, we've got a couple of slides to go through. So first, make sure that you go through the unit circle on the help session slides on the announcement board. It does give you some tricks to reading the unit circle as well as some patterns that you can find on the unit circle. And the good thing is the unit circle never changes. So once you know those patterns, you're good. So one thing I do want to note before you refer to those help session slides is please note that you do have an X and Y coordinate point, and what those represent is the X value is always the cosine value. The Y is the sine value. And then in its own parentheses is going to be the tangent value. So it goes in alphabetical order, cosine, sine, and then tangent. Um, Also, one thing I'd like you to note is that from your unit circle, they're broken up into quadrants, noting all students take calculus. So note that all students take calculus, quadrant one, two, three, four. Knowing this acronym just tells you what's positive in each quadrant. So, for instance, in quadrant one, all is positive, which means cosine, sine, and tangent. In quadrant two, only sine is positive. In quadrant three, only tangent is positive. And in quadrant four, only cosine is positive. So just make a note of that. Make sure you look at the help session slides on the unit circle. And today we're going to cover the arc length of a circle as well as right triangle trigonometry. So keep in mind that for the arc length of a circle, when you're calculating the arc length, which is S, the angle should always be in radians. And you multiply it by the radius of the circle. So looking at the first example, you're going to find the arc length of the circle given theta equals 3 pi over 2 with the radius of 5 centimeters. So I'm going to draw out a circle. Say it has 5 centimeters and it has an angle of 3 pi over 2, which is down here. Theta equals 3 pi over 2. So what I'm actually finding is the arc length, which means the distance from here, 0, which is where we always start, all the way to 3 pi over 2 of this circle. So that would be the value of S. So to find this S value, I'm going to apply the formula theta times R. So S equals, and my angle, note it's already in radians, so I don't have to convert it. If it is in degrees, make sure you convert it into radians. And my radius is 5 centimeters. I'm going to keep this in fraction form. So the fraction form of 5 is 5 over 1. And then to multiply fractions, I go straight across, giving me 15 pi over 2 centimeters. That is my arc length. That is the distance from here to here. And then for the next problem, given an angle of elevation of 34 degrees. So if I draw out a right triangle, because it does tell me it is a right triangle, the angle of elevation is right here, 34 degrees. If I was talking about this angle up here, this would be known as my angle of depression. So keep in mind, the angle down here is known as the angle of elevation. The angle up here is known as the angle of depression. And then I have my right angle. I'm also given in my right triangle a hypotenuse of 20. And with that, I'd like to find the adjacent side of the right angle. So, or right triangle. So the adjacent side is always the side that the given angle sits on. So note that 34 degrees is sitting on this side, which is the adjacent side. Keep in mind, because if I were to change the angle up here, this would be the adjacent side. So the adjacent side is always the side the angle sits on. In a right triangle, when I'm given sides and angles, I don't use Pythagorean theorem because I only have one side. For Pythagorean theorem, I would have to know 2 out of the 3 sides. So when I'm given an angle and a side of a right triangle, what I apply is SOHCAHTOA. So keep in mind SOHCAHTOA, sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. So in this case, I have the hypotenuse and I'm looking for the adjacent side. So the one that uses adjacent and hypotenuse is cosine. So setting up my equation, I'm going to write cosine theta equals adjacent over the hypotenuse. You cannot take a trig function without taking an angle, so make sure you note theta. So filling in what I know, I have cosine of 34 degrees equals the adjacent side, which I don't know, I'm going to call it as x over 20. And then the goal is to just get x by itself. So from here, x is being divided by 20. So to get rid of that divided by 20, I'm just going to multiply 20 on both sides. So from there, I have 20 times cosine of 34 degrees equals x. You're going to put it in a calculator, calculate it, make sure that your calculator is in degrees. DEG is what it will say on the bottom of the screen, because otherwise, if it's in radians, your answer will come out incorrectly, even if you have the correct work. Other than this, please make sure that you review the unit circle. I hope that this helps.